Hi children, welcome back to the class. In the last class we have learned about the atomic radii and its periodicity. Now in goal 4 and 5, which is entitled as the ionization energy, the second periodic property. Let us define and see what is this ionization energy is all about. So, ionization energy defined as it is the amount of energy required to remove an electron from a gaseous atom. In a simple way, if you take a metal, suppose electron is being removed from this. So, we get M plus 1 electron. So, delta H, which is written as IE1. This is first ionization energy. Now, followed, if one more electron has to be removed from this isolated gaseous ion, this is the atom and this is the ion. Now, we get here M2 plus 1 electron gives us the delta H. This is the IE2. So, likewise, this we call it as the first ionization energy. Then the second ionization energy is also similar, because the amount of energy removed to amount of energy required to remove an electron from the gaseous ion. And here a point to be noticed is that the first ionization energy will be lesser than the second ionization energy, or we can say second ionization energy is always greater than the first ionization energy. If you take an example, that is the first ionization energy of nitrogen atom is greater than the first ionization energy of oxygen atom. In this, if you write for the nitrogen atomic number 7, 1s2, 2s2, 2p, 3. Okay. So, here we notice these two are completely filled and the p orbital here is half filled. So, we know that half filled and then completely filled are more stable. So, since it is half filled, so it is stable. When come to the oxygen, which is atomic number is 8, 1s2, 2s2, 2p4. That means here it is incompletely filled or partially filled. So, it is easier to remove electron. So, incompletely filled, therefore, it is unstable. Got it? But when we go for the second ionization energy, second ionization energy of oxygen is greater than the second ionization energy of nitrogen. Why? Because here now already one electron is removed from the nitrogen, so it will be n plus. So from the 7 we minus 1, it is 6, 1s2, 2s2, 2p2. So it has got only 2 electrons. So therefore it is incompletely filled, so unstable. Whereas for the oxygen it is 8 minus 1, it is 7. Now half filled, so more stable. So from this it is clear that second ionization energy will be always greater than the first ionization energy. Okay. Now it is measured in terms of the kilocalories per gram atom, or it is measured kilojoules per mole, or it is also measured kilocalories per atom. So the simple convention is 1 electron volt. It is also measured in the volts. 1 electron volt is equal to 23.06 kilocalories, or it is 96.03 kilojoules. Okay, these are the units, or in this way the energy is being measured. The energy required to remove an electron is measured in this way. Next, as we are intended to discuss the changes, the gradations, periodicity along a period and across a period and down the group, we also need to see the factors that determine the ionization energy. Okay. First, let us discuss changes or the gradations across a period from left to right. From left to right. Changes or variations in a period. Okay. As we move across a period, when we move across a period, what happens is the ionization energy increases. Ionization energy increases because you know that the distinguishing electron will be always added into the same orbital. So due to which the extra nuclear charge will pull the electron more towards it, and there is a strong attraction between the nuclear charge and the valence electron. So therefore you require more amount of energy to remove the electron. So therefore we put here the ionization energy increases. But when we move down a group, the differentiating shell, as we move down, always a new shell is being added. So because of this extra energy shell, the atomic size increases, and the distance between the nucleus and the valence electron widens, increases. So therefore the attraction between the nuclear charge and the valence electron weakens or decreases. As a result, we require very less amount of energy to remove the electrons. So therefore we say, when we move down the group, the ionization energy decreases. So, these are the variations in the period and down the group. But we need to see the or list down the factors that are responsible for this. So, factors affecting the ionization energy are: first one is the atomic size or the atomic radii. Second is the nuclear charge. Third, screening effect or the shielding effect. Fourth is the penetration power. Fifth is the electronic configuration or from which subshell it is being removed. So, we can say it as the orbital from which the electron is being removed, orbital. And the sixth one is the net charge on the atom. Okay. We will quickly review this. As we look at the atomic radii, when we move across a period, we understood that the ionization energy increases. Okay. So, smaller the size of the atom, the greater the ionization energy required, because when the size is small, the valence electrons are more closer to the nucleus. So, therefore, there is a strong attraction between the nuclear charge and the valence electron. So, we require more amount of energy to remove the electron. So, the size and the ionization energy are inversely proportional. They are inversely proportional to the ionization energy. Larger the size, the lesser the amount of energy required. Smaller the size of the atom, the greater the amount of energy required to remove an electron. Okay. Now, coming to the nuclear charge. Nuclear charge is directly proportional, because as the nuclear charge keeps on increasing, there will be more attraction between the nuclear charge and then the valence electron. So, therefore, the valence electrons are held more strongly. Therefore, we require more amount of energy. So, we can say here the nuclear charge is directly proportional to the ionization energy. The screening effect. As we know in the earlier class, we have already understood what is meant by screening effect or the shielding effect. The presence of the electrons, inner electrons between the nucleus and the valence electron decreases the attraction between the nuclear charge and the valence electron. So, this decrease in the attraction between the nuclear charge and the valence electron is known as the screening effect. Okay. So, more the number of inner electrons, the greater the screening effect. So, the lesser the amount of energy required. So, here we can say the screening effect is inversely proportional to the ionization energy. As the number of shells increases, the number of inner electrons increases, and there will be more of the screening effect. So, as the screening effect is more, the nuclear charge effect on the valence electrons will be less. So, therefore, we will be requiring less amount of energy to remove the electrons, right. So, it is inversely proportional to the ionization energy. Now, penetration power, as we know, the s orbitals will be more closer to the nucleus. So, the nuclear distance between the orbitals plays very important role. So, the order is in this way, the penetration S, you will be having the requiring more ionization energy, the p orbital requires more ionization energy than the d orbital requires the more ionization energy than the f orbital. So, we see here f orbital will be more further away from the nucleus, therefore, there will be less nuclear charge on the valence electron. So, therefore, it is more easier to remove the electrons. Now, coming to the next one is the net charge on the atom, the net charge on the atom. So, the net charge is directly proportional to the ionization energy. We can take example here, Al3 plus requires more energy than the Al2 plus, and Al2 plus requires the more energy than the Al plus. So, the greater the charge, the greater the ionization energy. So, we can say here the net charge is directly proportional to the ionization energy. The greater the charge on the atom, the more the energy is required to remove an electron. Okay. So, to conclude, we will just take one example across the period and down the group and see how these factors will be affecting. We will take the example of the first group elements and the down the group and across a period. We will take the elements of the first period, that is the lithium, beryllium, boron, carbon, nitrogen, oxygen and fluorine. Here lithium has got 5.23, then you got 9.45, 8.23, then we got 11.24, then you got 13.65, got 14.2, then we got here fluorine as the 21 point, or you can take it as 17.75. Okay. So, when you see these, the numerical values that are given here for the lithium, beryllium, boron, you see here there is a amount increase in the ionization energy, then there is a slight decrease here, then again increase, and then as we come more to the extreme to the right side of the periodic table, we see the ionization energy, the amount of energy required to remove an electron increases. Basically, the size decreases, the attraction between the nuclear charge and the valence electron is greater. Okay. In the same way here, if we take the example of the lithium, then the sodium, potassium, rubidium, okay. Then this is 5.45, then potassium we see 4.2, rubidium 4.2, then the cesium it is 3.03. So, you notice that here the values are decreasing, So, this clearly indicates as we move down the group, As you move down the group, the amount of energy required to remove an electron is less due to the screening effect, and the extra energy shell. So, when extra energy shell is being added down the group, the distance between the nucleus and the valence electron increases. As a result, the attraction between the nuclear charge and the valence electrons decreases. So, therefore, it becomes more easier to remove the valence electron, resulting the less amount of ionization energy required. So, this is the second periodic property that keeps on repeating at a regular intervals. Okay. So, that is why it is very important and necessary for us to learn these periodic properties. So, in the next class we will be learning about the other periodic properties. The leftover are, we got the electron affinities leftover, and then we got the electron affinity, and then we got the next valence is there, oxidation number is there, then the electronegativity is there. So, for all these, most of the time the factors that we have listed before, what are those? Yes, atomic size, nuclear charge, penetration power, okay, electronic configuration, the net charge, all these factors equally play important role in deciding the characteristic properties and the variations. So, I wish you all the best in your learning. So, we will meet in the next class to discuss the electron affinity. Till then, have a nice time, enjoy your learning. Thank you.